So the first thing we're going to talk about is solving proportions with the giant one method. You can basically, this is something you've actually learned before. We used a lot when we're creating equivalent fractions. So like, for example, if I wanted to take 2/3 and multiply it by 4 over 4. Well, 4 over 4 has a value that is equivalent to a giant 1. It's an equivalent form of 1. But if we use our techniques for multiplying fractions and we multiply the numerators to get 8 and we multiply the denominators to get 12, what we've just done is created the ratio or the proportion 2/3 equals 8 over 12. So this is these two fractions are equal because I multiplied by a value that was equal to 1. Well, we're going to use that idea to solve a bigger problem, to solve for an unknown value. In problem 153, Kenny's class found several ways to solve 10 sevenths equals x over 1505. 3 of the strategies that they used are presented below. Some of these strategies might be the same as what you did on 152, however, others may be new. Work to understand each strategy so that you could use it to solve a new problem. So the giant 1. Multiplying a ratio by 1 does not change the value of the ratio. You can write 1 in many forms, such as 3 over 3 and 14 over 14. In this course, this kind of fraction is called a giant 1. Find a value to use as a numerator and denominator in a giant 1, and then find the value of x in the equation below. So, if I were to take and solve this problem, 10 over 7 times some equivalent form of 1, a giant 1, equal to x over 1505, I would really need to figure out what I have to multiply 7 by to get 1505. So in my head, so here's me, and I'm thinking to myself, how many 7s go into 1505? 1505 divided by 7 is 215. So my equivalent form of 1 is going to be 215 over 215. So 7 times 215 is 1505, and 10 times 215 is x. So let me write that down. 10 times 215 is equal to the x I'm looking for. So x must equal 2,150. That is the giant 1 method. Find a value of an equivalent value of 1 and use its use your methods of multiplying fractions to find the missing variable.